Morning, Albert. Hindi ka sa gawas.
Morning, ma'am.
Okay ra mo internet nila.
Morning, ma'am.
Morning. So it's 7:40. Mag-start na ta class. We have pila na lang ka minutes left. 50 minutes left na lang. Okay ra mo internet dira, Albert?
Wala tingog, ma'am.
Nakamute ko. Okay, so again, we have the cylindrical coordinates, which can be described by S, V, and Z. So here is a somewhat not so good illustration of the cylindrical coordinate system. Okay, so you have here a point P. So this point P can be expressed in terms of the Cartesian coordinates X, Y, and Z, right? And we can also express this in terms of the spherical polar coordinates R, theta, and phi. Okay, so aside from the spherical polar and the Cartesian coordinates, we can also express it, or we can also define it in terms of cylindrical coordinates. Okay, so suppose we have a point P here, then we can make a cylinder that is centered at the z-axis. So this cylinder is centered at ang center niya class is positive z-axis for this example. And then point P coincides with the body of the cylinder. Okay, so it coincides with the body of your cylinder. Now S is the distance to the point P from the z-axis. Okay, so anywhere from there is a z-axis towards the body of the cylinder, or more specifically, ikan there is a z-axis padulong sa imong point P that is equal to S. So the distance between the positive z-axis and your point P is equal to S. And then phi is kini siyang angle class around the x-axis. So kung asa mo point, okay, so kini siya nga angle, for example, imong point P kay naa there is somewhere in the first octant. Okay, so naa siya sa first octant. So tracing, i-trace na to ni si S din sa ubos. And then this is your angle phi. Okay, so it is the angle around the x-axis. And then z is just the same as that of the Cartesian coordinates. Okay? So here is the relationship with the Cartesian. So the relationship with the Cartesian. All right, so x. So if you're given with S, phi, and z, then you can find x. You can convert it into the Cartesian coordinates. Okay, so kung given, pwede siya na ito ma-convert into Cartesian coordinates. You have x equals S cosine phi. Okay, so as you can see here, if you make so this one, ano siya class na imo ang x. Kini siya imo x, kining along the x-axis, y, and then z. So kini siya nga side diri. This is just adjacent to your angle phi. So the length of this side is equal to S cosine phi because kini siya nga length diri a class, the hypotenuse. Mura siya, the hypotenuse of this right triangle formed by kini, the x, the hypotenuse, and then this one. Kini siya, this is equal to S. So again, any point gikan sa z-axis padulong sa body sa imong cylinder kay sa ganina siya, S ang iyang length. Okay, so this side here, or kini siya nga, kini siya nga line diri ang iyang length kay S. Okay, therefore, kining X is equal to S cosine phi. And then your Y is this one. So, as you can see, from this right triangle also, okay, so this is equal to S sine phi because this length here, kini siya nga length, is just equivalent to your Y. Alright? So it is the side opposite the angle phi, so you have S sine phi. And then your Z is just equal to Z. Okay? Now for the unit vectors, so for the unit vectors, S hat, P hat, and Z hat, we can relate this to the Cartesian unit vectors. So this one is just equal to cosine phi x hat plus sine phi y hat. And then your phi hat is equal to negative sine phi x hat plus cosine phi y hat. And of course, your z hat is just equal to z hat. Okay, now take note also that for this unit vectors, only z hat is constant. Okay, so si s hat class varies. Mag-vary siya with respect to the point. Depende sa point kung asa siya. And then phi hat also varies. Okay, so wala siya fixed nga direction. Okay, now, i-drawing na to balik, no? Ang cylinder. Okay, so this is your z-axis, your y, and then this is your x. Okay. Now, suppose your point is in the first octant, okay? Or, okay, so first octant, yes. For example, na siya sa first octant. Again, the body of your cylinder should pass through the point class. The point P. So, para so, na siya. Okay. So, again, kini siya nga point, ang body sa cylinder class. Okay? So, this one is your Z. Kini siya, Z. So, Z hat is fixed. Of course, nasa diri. Unit vector along the positive z-axis. And then, ang imuang phi hat, your phi hat class is, again, it is tangent ani. Okay? Tangent siya ani. Tangent siya ani nga circle. Okay? So, it's tangent to this circular path, or kung diri ta sa point, nasa diri padulong, it is pointing into the direction of maximum increase. It is tangent to the circular, so pwede ka magbutang diri og trace diri og circle around the body of your cylinder nga moagi sa point. Okay, so imo ang phi hat class is kini siya, no? Tangent ani. And then z hat is padulong diri. So this is your z hat. And then your s hat is gikan diri sa positive z-axis padulong diri man s. Kini siya man s. So extend lang na siya na to. So that is the direction of your s hat. These three are mutually perpendicular regardless of where the point is. Okay? So your s hat, z hat, and phi hat are mutually perpendicular. Okay, now for the infinitesimal displacement, so it is important that we know the infinitesimal displacement in terms of the cylindrical coordinates. All right, so you have dl s hat, dl along the s is just equal to ds. And then you have dl phi. This is just equal to s d phi. And then your DLC, this is just equal to dz. Okay, so that the infinitesimal length, is just equal to, you have dlss hat plus dl phi hat plus dlz z hat. Okay, so this is equal to ds s hat plus s d phi hat plus gz z hat. Okay, so that is the infinitesimal length. And the infinitesimal volume, you have d tau, it is equal to, you just have to multiply all of this, dls, dl phi, and dlc. So you have s ds d phi dz. Okay, so you have s ds d phi dz. By the way, class, your z stands from the negative infinity to positive infinity. Okay, now let us express our vector derivatives in cylindrical coordinates. Okay, so let's start with the gradient. So how do we express gradient in terms of the cylindrical coordinates? Okay, so you have the partial derivative of t with respect to s hat plus 1 over s multiplied by the partial derivative of t with respect to phi hat plus the partial derivative of t with respect to z hat. So this is our gradient in terms of the cylindrical coordinate. Okay, now for the divergence, so you have the divergence of v. This is equal to 1 over s multiplied by the partial derivative of s times, we can also call this the radial component of your cylindrical, of your vector class, vector function. So you have 1 over s multiplied by the partial derivative of s times v sub s plus 1 over s multiplied by the partial derivative of v phi with respect to phi, and then wala na ni si phi hat, of course, and then you have the partial derivative of v of c with respect to z. Okay, so this is the divergence in terms of the cylindrical coordinates. And then for the curl of a vector function, you have 1 over s multiplied by the partial derivative of v sub z with respect to phi minus the partial derivative of v sub phi with respect to z. So this is your S component. Z minus the partial derivative of v sub z with respect to S. So this is the phi component, the azimuthal component, and then you have the last term is 1 over S multiplied by this quantity partial derivative of S v phi. So you have the partial derivative of S v sub phi with respect to S minus, shall I write it here? Minus the partial derivative of v sub S with respect to phi. Okay. So this is the Z component of the curl. Okay, so this is the expression of the vector derivatives in cylindrical coordinates. How about the Laplacian? So for the Laplacian in terms of the cylindrical coordinates. Nakasulod na ka, Albert?
Yes, ma'am. Yes, ma'am.
Na naka sa office?
Nakadiri, ma'am. Sa gawas.
Okay, okay. So the Laplacian in terms of the cylindrical coordinate. So you have this expression 1 over S multiplied by the partial derivative of S times the derivative of F with respect to S. I think this is partial derivative. So 1 over S multiplied by the derivative, the partial derivative of this term with respect to S plus 1 over S squared multiplied by the second partial derivative of F with respect to phi squared. And then you have the second partial derivative of F with respect to Z. Okay, now let us express the Cartesian unit vectors in terms of the cylindrical unit vectors. Cartesian unit vectors, no? Cartesian unit vectors in terms of cylindrical unit vectors. Okay, so you can visualize this one class geometrically. So you have x hat equals cosine phi s hat minus sine phi hat. Okay, and then your y hat is equal to sine phi s hat plus cosine phi hat. So if you have time, pwede na siya ninyo i-derive class or I think na mo'y derivation ani sa inyong mathematical physics. Just review your notes and then you have z hat is just equal to c hat, of course. Okay, and then let us also relate the Cartesian relationship between the cylindrical coordinates
Hala, gamay ra lagi tang nag-attend. Ay, open mic man ligat.
Nawala ko si ma'am.
Ano mo? Nawala ang internet? Okay, so kaganina murag gidrawing na to ang kuano. So if this is your saan siya class? This is your z-axis. Ang imo ang s kay kani. If this is the z-axis, this is your s. Okay? So muna siya imo ang s, mura siya radius sa imo ang cylinder. Yeah, it is the radius of the cylinder. Now, this is equal to the square root of x squared plus y squared. So, since ang imo ang cylinder class kay naa siya along the z-axis, no? This one is in terms of the x and y coordinates only. Balik nito itong drawing ka ganina. Okay, this one. Muna siya imong s, no? So, this is your s. Pareha na siya length aning gibuhat na to nga s diri gikan sa positive z-axis padulong sa imong point P. So, the same length as this one. This is s. Now, kini siya. This is x and then this is y. Okay, so x and then y. So, if you make a right triangle out of this, so si S kay mo ang hypotenuse. Tapos kini siya nga side is your x, your y. Therefore, by Pythagorean theorem, you can get S in terms of x and y. Okay, so you have S is equal to the square root of x squared plus y squared. And then phi, your phi is the angle between the positive x-axis and your s. So you can just use the arctangent of y over x to find phi. So, ano na siya pa sa kung given imo ang x, y, and z and then you want to know its cylindrical, you want to express it in terms of the cylindrical coordinates, then you can just use these equations. And then your z is just equal to z. Okay, so let us solve this problem. We have problem here. So given this vector function s multiplied by 2 plus sine squared phi s hat plus s multiplied by sine phi cosine phi hat plus 3z c hat. So let us find the following. So the first one is to find the divergence of V. So this is just some sort of practice. And then you have the curl of V. Okay, so the first one is to solve for the divergence. Okay, so this is our vector function, and then we have to get the divergence of that vector function. Okay, so let us take a look at our divergence in terms of the cylindrical coordinate. So you have this expression. Okay, so natiman-an na to ninyo. So you have 1 over s multiplied by the partial derivative of with respect to s of this. So naa kay s multiplied by v. Vs ba to? Okay. So 1 over s multiplied by the partial derivative of s v sub s with respect to s plus 1 over s multiplied by the partial derivative of v sub v with respect to phi plus the partial derivative of vz with respect to z. Okay, so this is the divergence in terms of the cylindrical coordinate. So you have s multiplied by 2, napay s day class. 2 plus sine squared p plus 1 over s multiplied by the partial derivative of this one. So you have s sine phi cosine phi. And then you have the partial derivative of 3z with respect to z. Okay, so let us each evaluate this. So nakay 1 over s. Sa itong buhaton na ni class. Ito lang siya i-distribute the factors. We will distribute the factors. So nakay 2s squared plus s squared sine squared phi. Sakto ra ba ni? Plus 1 over s. We just have to copy this one. So s sine phi. Maot kay ang s lang taon class na. Actually kay si Griffiths so yata ang gagamit og s. Ang uban kay R gyapon ilang gigamit. But in order to differentiate or distinguish between katong R sa spherical polar coordinates o kini siya no s iyang gigamit. Okay, so let us evaluate this one. Dili lang guro class para makita na 1 over s. What is the derivative of this with respect to s? For s, no?
Yes, ma'am.
Yes, ma'am.
Okay, so it's 4s plus,
2s.
since this is partial derivative, which we can consider this as constant. So you have s squared. You have sine squared phi. This is the constant. I-copy lang siya na to. Tapos, the derivative of s squared. So it's 2s, right? 2s. Okay, so you have 4s plus 2s sine squared phi. Ito ba ni? Plus this one. 1 over s. So, ang ano siya, class? Pagawas na to si s because this is a constant. Ipagawas na to daan si s sa derivative nga sine, kini siya. Since this is a constant, okay? And then we will evaluate this one. So, saan ni siya? Derivative of f times g is equal to df g minus g df. It's f dg. Sakto ba ni class? So it's equal to f dg plus g df. So meaning to say, ang man atong f ani, so pwede kini si sine phi atong f, g is cosine phi, so multiplied by sine phi. Unsay derivative sa cosine phi, class? Negative sine phi?
Yes, ma'am.
Sakto ba? Plus g. So g is cosine phi multiplied by the derivative of sine phi, which is
Cosine phi.
cosine phi. Okay. And then this one is 3. Okay. So let us simplify this one. So kini siya klase, pwede na to i-distribute din nato si 1 over s. So ang mapili na lang dire kay 4 plus 2 sine squared phi. And then here, cancel out na po ni si s. S times 1 over s just equal to 1. And then kini din atong i-simplify. Okay, so I hope inyo tong ma-visual, inyo tong ma-recall. So you have 4 plus 2 sine squared phi. Sakto ba ni? Plus kini siya nga term. So, pwede na to isulat as cosine squared phi. Kini siya kay minus sine squared phi. So, you have cosine squared phi minus sine squared phi plus 3. Okay. Napabatay na limtan nga term. Wala na, no? Now, so, ano na siya na to? Pwede na siya na to ma-add. Sine squared phi man siya, tapos na po kayo isa ka sine squared phi. So you have, i-add po nina to si 4 og 3. So you have 7 plus cosine squared phi. And then kini siya class 2 sine squared phi minus sine squared phi. That is just equal to positive, no? Positive sine squared phi. Sakto ra ba ni? So you have 7 plus, now take note that this term here is just equal to kadungdung cosine squared theta plus sine squared theta is just equal to 1. Okay, so this is just equal to 1. Therefore, you have 7 plus 1 equals 8. So this is the divergence of the vector. Class, medyo taas-taas to, no? So, yes, naikuan, comments? July?
Ma'am.
Yes, Albert.
Saan siya nga may
Ano sa to?
Katong DFG, ma'am ba?
DEG. So, DEG.
Katong gaganyan bitaw, ma'am.
Okay. One, derivative of a product.
Derivative of product.
Inyo guro na ano yun, dumduman kay DU equals UDV minus plus VDU. Dumduman siya ang nakakalkils siya U and V. So, magigamit rin siya nato para ma-differentiate ni natong sine phi, cosine phi.
Thank you, ma'am.
Okay, for the curl, so you have the curl of V is equal to, sige, ito itong term class, 1 over S, partial derivative of VZ. So VZ is 3Z over V. So partial derivative of the Z component with respect to phi minus the partial derivative with respect to S of the S component, phi component rather. So you have S sine phi cosine phi S hat. And then the second term is partial derivative with respect to Z of Vs, V sub S. So your V sub S is S multiplied by 2 plus sine squared phi. Okay. Minus the partial derivative with respect to S man siya, no? With respect to S of VZ. So your VZ is 3Z. Okay. So this is your P component. And then the last term is you have 1 over S multiplied by the partial derivative with respect to S of V phi. Yeah, V phi. So you have S times, so kining S diri kas kay nani siya daan sa equation. Tapos kini siya, this is your V phi. So you have sine phi, cosine phi. S sine phi, cosine phi. Minus the partial derivative with respect to phi of S. And then you have 2 plus sine squared phi. Okay. So, dali siya madumduman kay kung unsa imo ang gi-differentiate. For example, kini siya no, VZ with respect to phi. Sunod kay i-differentiate siya nimo minus with respect to Z, tapos kini kay mo man imong VP. So, except for the last term, na naa siya 1 over S nga factor o kining S. Okay? So, dali ra madumduman ang curl. Alright, now this one, derivative of Z with respect to phi, so this is equal to 0. Constant naman ni si Z diri a class because we are differentiating with respect to phi. And then this one also, you have integrating with respect to Z, wala tay Z, so this is equal to 0. Here we are differentiating with respect to Z, so wala pa tay Z diri. This is 0. This one also is 0. So the first two terms kay nag-vanish, ano? Ang habilin is this. So let us evaluate this one. So naman kay S, differentiating with respect to S, so naman kay mga S diri ah. Okay, so this is equal to 1 over S multiplied by the quantity. This one. So, na kay S squared, sine theta, cosine theta. So, we just have to consider this as a constant. So, you have 2S. So, S squared, derivative of S squared is 2S. And then here, we will differentiate with respect to phi. So, ika-p lang ni nato ning, so na kay 2S, no? Sa isa ka term. And then you have this one, minus the derivative of this. So, na kay 2S times, 2S plus S sine squared phi. So, ato lang i-differentiate is kini si S sine squared phi. So, how do we differentiate that one? So, ma-zero na to nga term. Minus, sakto ba ni? So, minus this term, which is, ma-zero na ni siya, plus, di ay siya, plus, S, the derivative with respect to phi of S sine squared phi. So, saan mo na siya pag-differentiate? So, this is your Z hat. Kini siya tanan kay Z hat na siya. Z hat na lang ang term ang habilin. So, ang ganyan pag-differentiate class? Okay. So, diri no? Na ganita. Kini siya. So, dili lang ni siya 2S. Kaya na pa din nga factor, kining constant. So, it should be 1 over S multiplied by 2S times this constant here. Kining sine phi, cosine phi. Sorry. So, na kay 2S sine phi, cosine phi. Sakto ra ba? Ito na class? No? Dili ni siya kay constant. Naaman ni siya diri. So, we will differentiate this with respect to S. So, ang mabilin is 2S sine phi, cosine phi. Minus, kini siya nga term. So, kini siya ang ma-0. Tapos, this one dayon. Adjust lang. Siya isulat. Sulat na to ha. Side note. So na kay 2s plus s sine squared phi. So since we are differentiating with respect to phi here, so kini siya wala na ni 0. Tapos kini unsay kuan ani class? Unsay derivative with respect to s. So magkuan ta no? With respect to phi. Mag-change variable ta. Let u. So na kay 1 over s 2s sine phi cosine phi, and then minus kini siya nga term. So change variable, let sakto ba? Or unsay derivative sa sine squared theta with respect to theta?
Sine squared theta.
Unsa to? Mag-let u man ta na no, derivative of sine squared theta. Sine squared theta. Chain rule. So we can use chain rule, and it is equal to 2 sine theta cosine theta. Okay. Yeah, you can use chain rule. Mag-let u kani. So this is equal to 2s sine theta cosine theta. Let u be equal to sine theta. So du is equal to, so may derivative sa sine class, cosine. So you have u squared. Wala akong gibuhat. Basta, ang answer ani class is, ang derivative sa derivative of sine squared theta with respect to theta is equal to 2 sine theta cosine theta. Okay. Since napa may s dire, so nakay s factor here. Okay? So this is your z hat component, but okay, so this one is just the same as this. So we will also get 0. So the curl, walay curl. Sa ganit tawag ani ba sa walay curl class? Solenoidal? Or sa ganito? Sa ganito yung master, irrotational na solenoidal. Pag curl of a vector is equal to 0, ang sa term ana? Albert? Irrotational? Okay, so it's irrotational.
Rotational.
Okay, so it's
Oh.
irrotational.
Hindi siya mag-run.
All right, so it's 8:30 and I have a class at class 12. So this ends our discussion today.
Ma'am, upload niya po ni ma'am.
Ha?
I-upload niya po ni ma'am later.
Yes, ako na i-upload later. Na-upload na tong uban kas.
Thank you.